What's up everyone, my name is Andrew Fung. So today I'll be showing you how you can approach a dataset using Python Pandas and to do some basic operations to tackle the commonly asked questions or tasks of data scientists. So in this video I'll be covering the data filtering, data grouping, quick plotting, and also some basic mathematical operations such as the mean of a dataset or a group. So the reason why I'm making this video is because I realized that the last couple of videos the topics are kind of from intermediate to advanced. So in this video I'll be sticking to the basics of Python Pandas and also to tackle the frequently asked questions that students may come across or data analysts may experience it in everyday life. So without further ado, let's get started. So for the dataset, we'll be using this dataset, which describe the sale prices and informations of the properties sold in Washington, D.C. So I believe the earliest record of this dataset is 1982, and the most recent record is 2018, which is shown here. So there will be different attributes inside this dataset to predict how much this property may cost, such as the number of bathrooms, what type of heating device, is there AC in that apartment, etc. So let's first load in the data frame. So let's import pandas SPD, and to read in the data frame we do pd.read_csv. And the dataset name will be dcproperties.csv. And let's look at the first few rows. So we successfully load in the dataset, as you can see. So the first task is to find out how many properties were sold in June 2015. And this question will test our understanding on filtering, which is to filter the dataset that matches the requirements, which is the month will be June and the year will be 2015. And let's look at the columns. We can see that there are different attributes, and the one we are looking for is sale date. And let's see what this column is about. So it's essentially recorded the sale date when the properties were sold. So what we can do is to first turn this column into a datetime object. So we can do that by data frame sale dates equals pd.toDatetime, and then put in the same thing. And then let's set the two filters. So the first filter will be the month filter, which is data frame sale date, and then we map this to a lambda function which extract the month and then make it equal to 6. And the year filter will essentially be the same thing, but we extract the year. Lambda function x.year equals to 2015. So these two filters are valid because we turn the whole column into a datetime, so that it is no longer a string, it is a datetime object, so that we can extract the month and the year from that. And let's do a required month that is specified by the questions, which is data frame. We put in the month filter and the year filter. So let's see how it looks like. So when we look at this, we can check the SALEDATE of this subset of a dataset. We can see all of the entries are from 2015 June. So that works. So to answer the question, we can just do print length of the required month, which is 754 properties were sold in this month. And let's move on to the next question. So the next question will be asking us what is the most common type of heating mechanism and how many properties have it. So we can just do the heating mechanism will be the heat attribute. So we can just do data frame head.describe, which is a shortcut method to show what this column is about. So we can see there are 97,000 entries, and the top entries will be forced air. So the most common type of heating mechanism is forced air, and with the frequency of 39,238 properties that are equipped with forced air. So let's move on to the next question. Based on the mean price, which neighborhood is the most expensive? And the question requires us to use the column assessment NBHD, which is stand for neighborhood, for the neighborhood. So the question is asking us which neighborhood has the highest mean property price. And to tackle this question, we can just first take a look at the assessment.nbhd column. So we can see that the assessment.nbhd has all kinds of values of all kinds of neighborhoods, such as Georgetown, Brooklyn, Glover Park. So we first need to do is to group the entries with the same neighborhood together and then compute the mean price. And after we have computed the mean price of all the neighborhoods, then we can just rank them based on the mean price. So let's do that now. Data frame.group by. We group by the neighborhood, so it's assessment NBHD, and we compute the price, the mean price. So we take the mean, and let's see how it goes. So we have all the neighborhoods, Berkeley, Brentwood, Brightwood, Brooklyn, all the neighborhoods, and compute their means. So we need to sort them by sort the values in descending order. So it's false. And then let's read the first few columns. So we can see Massachusetts Avenue Heights has the highest mean property price. And if you want to show the entire number instead of just scientific notations, then we can just do pandas.set options, set the float format to display in full. Okay, and for the last question, it asks us, is the mean price of the most expensive neighborhood statistically different from the mean price of the second most expensive neighborhood? So for question C, we can see that the highest, the most expensive neighborhood is Massachusetts Avenue Heights, and the second highest is Berkeley. So we have to compare whether the two neighborhoods have statistically different mean property prices. So we can compare the two with percentage. So let's do that by MAH. Let's set the mean is equal to data frame dot group by assessment NBHD, just like the last question. We get the price, we get the mean as well, and then specify MAH, which is Massachusetts Avenue Heights. And for the Berkeley, which is the second place, we can just do Berkeley mean is equal to the same thing. But in here it's Berkeley. And let's print their percentage difference. So we can find that by MAH mean minus Berkeley mean divided by Berkeley mean. So let's see. So it shows that MAH is 78.3% more expensive than Berkeley. So the answer to this question is yes. MAH, which is the most expensive neighborhood, is statistically 78.3% more expensive than Berkeley, which is the second most expensive neighborhood. So we can quickly visualize the neighborhood mean price to check if our results are right. So we can do that by data frame dot group by the price dot mean. It's the same thing. And then plot this out. Or maybe change the figure size to be larger so that we can see clearly. And you can see that the mean is around maybe here. And one neighborhood is significantly higher than the others, which is the Massachusetts Avenue Heights, with over 2.6 million as the mean price of that neighborhood. Okay, and our answer to question D is most likely to be correct. So that's it for me. So the purpose of this video is to quickly show you how you can approach a data set and what's the steps to take when you see the questions that are frequently asked in maybe assignments or tests. Maybe as a data scientist, your boss may give you a data set and you'll be required to find out maybe how many sales were in a particular month, maybe which product is most sold, all this kind of questions, and which is kind of common. So I've decided to make this video to show you how you can do that and approach a dataset with more clarity. If you have any questions or doubts, then feel free to drop it in the comments below, and I will upload this dataset together with the code on GitHub, so feel free to check it out. Thanks for watching and see you in the next video. Bye guys.